titled What and When to Explain On-Road Evaluation of Explanations in Highly Automated Vehicles. This work was done with my great collaborators, Do Hyun-yeop, Tae-woo Jo, Daniela Ross, and my advisor, Seung-jun Kim. This study is about understanding passenger experience of different types of visual explanations while they are in highly automated vehicles. So we explore how this provision of explanations affect the trust, situational awareness, perceived safety, and many other measures, and how they affect the passengers' acceptance of automated vehicles. So let's begin with an overview of the background and the purpose of this study. So the increasing automation of vehicles are allowing passengers to engage in non-driving related tasks and having them spend their journey with more enjoyable and productive experiences. But the problem is that public anxiety hesitates this acceptance despite this ease and comfort, because passengers feel distrust and they feel reduced sense of control. And such tendency is fortified when the automated vehicles behave in a way that they could not have anticipated. And explanations in this regard can be a solution because they alleviate anxiety and promote passenger experience by providing increased sense of control. But the algorithms that are actually meant to generate explanations have not yet tested whether they actually promote passenger experience. And on the other hand, like researchers assessing the effect of explanations have been tested under inherently safe indoor environments and with a few association with the algorithms that actually have them implemented in vehicles. So connecting these distinctive research practice is essential to bridge the findings from each other and facilitate research regarding explanations in vehicles. So our study aims at testing algorithmic explanations on how they affect passenger experience. In doing so, we set the two research questions to guide our research. The first one is what types of explanations and when they should be provided on the road. And the second research question asks how do explanation types and timing mechanisms and the resulting passenger experience affect their acceptance of automated vehicles. To answer these research questions, we tested three types of explanations, which are perception, attention, and the combination of these, and two explanation timing mechanisms, having it provided continuously to the passengers and being presented only when there is potential traffic hazards. So our study features the tests of algorithmic explanations that were displayed on windshield display, and these were all tested using VR-enabled Wizard of Oz driving situations. Specifically, the Wizard of Oz system was intended to secure experimental safety and detour regulational issues. So in actual world, the vehicle is driven by a wizard driver, and passenger wears VR headset to enter the virtual world. And in the virtual world, here, the participants see themselves on the driver's seat, and the surrounding environment is streamed with 360 cameras. And this use of VR provides us a fast way to augment the windshield with algorithmic explanations. And for the algorithmic explanations, the image stream of the 360 camera, which is identical to the one that used for the Wizard of Oz driving, undergoes two different streams. The first one is to produce the perception information using the segmentation algorithm, and the second map is to produce attention map and to regulate the explanation timing. So we built a 3D CNN model to classify traffic risks based on car crash dataset and use the risk classification results to generate the risk adaptive information provision system. We conducted a pilot test with this algorithm to analyze participants' physiological responses. Our goal was to see if the risk level is correlated with their anxiety, and to ensure we provided explanations when participants appeared to need them most. And the grad cam attention to which the mother paid when determining the traffic risk were also used and presented as attention map. So this is those maps being augmented on windshield displays, and we have conducted user study on actual roads, including urban roads, arterial and local highway, with 30 participants. This is the video demonstrating the actual experiment. The vehicle is driven by a wizard driver, but participants are seated on the driver's seat in their VR environment, and they're subject to 7 distinctive conditions with varying types of explanations and varying types of regulating the explanation timing. As a result, the consistent provision of perception information improve usability, trust, perceived safety, situation awareness, and cognitive load. But presenting information depending on traffic risk levels were effective only when the information was overwhelming, with both segmentation and attention map presented. And in answer to the second research question, we also analyzed how the automated vehicles acceptance are mediated by the passenger experience changes under different types of explanations. Acceptance, which is characterized by willingness, self-efficacy, and attitude towards technology, were affected by the promoted understandability, perceived safety, and trust that explanations provided. So this is the final wrap-up for the study. So let's visit what and when to explain. Regarding the what aspects, the type of visual explanations refer with perception instead rather than the reasoning behind, and we believe this is predominantly due to the implicit nature of the attention map, which should be further tailored to provide intelligible explanations. And for regarding the when aspects, constant explanations was preferred because participants can judge themselves whether to engage with the explanation or not. But the risk adaptive explanations help to manage the excessive amount of information when both the perception and attention map were presented together. And for the second discussion, while our study features on-road experiments, it actually lies in a complementary relationship with indoor settings. So indoor experiments allows the evaluation of driving performance-related measures in safety-critical scenarios, and they provide more precise control for targeted testing scenarios. On the other hand, on-road experiments provides naturalistic scenarios compared to the indoor settings, and it provides enhanced ecological ability through real vehicles that is tested on actual roads. And for the third discussion agenda, which is limitations and future work of this study, our study could be enhanced with more diverse set of non-driving related tasks being engaged for our study participants, and our future work includes testing various modalities and regulating explanation timing, incorporating more nuanced driving and passenger context. Yeah, that is the end of the presentation, and I'll be happy to take any questions.
Thanks a lot, Kwangbin.